Picture a huge industrial plant, kind of like a sleeping giant made of steel and pure energy. You'd think it's most dangerous when it's wide awake, running at full tilt, right? Well, what if I told you that's not quite right? The most dangerous moments are actually when this giant is just waking up or when it's going back to sleep.
So let me ask you straight up. When you think about a massive industrial complex, what do you figure is the single most hazardous part of its entire operation? A sudden breakdown at peak production? Some kind of crazy system overload? Just give it a second's thought.
Believe it or not, the answer is way simpler than you'd think. The absolute highest risk, where most of the really bad stuff happens, is during what seems like a simple everyday task: startup and shutdown. Yeah, the real danger is hiding right there in plain sight.
Okay, so these phases have a name. They're called transient operations. And that's because everything is in a state of change. It's not the steady, predictable hum of normal work. This is when the plant is at its most unpredictable and its most vulnerable.
Think about it this way. Normal operation is the goal, right? Stable, predictable. It's routine. But a startup or a shutdown, that's completely non-routine. Everything's changing fast. Temperatures, pressures, you name it. And that's exactly why this is when you see the highest rate of incidents. It's a time that demands absolute focus.
So how in the world do you handle moments with such high stakes? Well, you definitely don't wing it. You have to operate with a really strict philosophy, a clear set of rules for how you deal with that sleeping giant.
And this philosophy boils down to 3, let's call them unbreakable rules. First, safety always comes before speed. Second, you have to follow every single step in the exact right order. And third, and this is a big one, you never, ever skip steps just to save a little time. These aren't suggestions, This is all about discipline.
Before anyone even thinks about pushing a button, that whole philosophy gets put into action with a pre-startup safety check. This means people are out there physically confirming all the mechanical work is done. They're making sure every single valve is in the right position, and they're clearing all the work permits. It's all about being 100% sure the system is ready for a safe start. All right, now we get to the main event, actually waking the giant. And let me tell you, this is nothing like flipping a light switch. It's this incredibly delicate, precise dance where even one tiny misstep can have absolutely massive consequences. And get this, not all startups are the same. You've got a cold startup. That's when you're bringing the plant online from a total standstill, basically from room temperature. The huge challenge there is managing thermal expansion as all that massive metal heats up. Then you have a hot startup, which is after a short shutdown. The big danger there is dealing with any leftover energy, heat, and pressure that might still be trapped inside the system.
Let's dig into those hidden dangers for a sec. If you rush a cold start, you can cause unbelievable stress and damage to the equipment. Different parts heat up and expand at different rates, and you can literally tear things apart from the inside. And with the hot start, that residual energy is like an invisible threat. A pipe you think is safe could still be holding high-pressure steam. One wrong move, and a simple task becomes a life-or-death situation.
And of course, putting the giant back to sleep also takes a lot of care. A normal shutdown is planned out. It's a gradual process designed to protect all the equipment. But an emergency shutdown, an ESD, that is a totally different beast. That is the last line of defense. It's a system built to protect lives and prevent catastrophe, period. And after an ESD, you can't just flip it back on. You need full authorization to even think about restart.
But, procedures and fancy systems, they're only part of the story. The most critical safety component of all is the human element. It's the team on the ground that is the only thing standing between a smooth operation and a potential disaster.
And this teamwork really comes down to 2 key roles. You have the field operator, they're the eyes and ears out on the plant floor, physically checking on the equipment. Then you have the control room operator, who's managing the whole sequence from the control panel. They really have to work like 2 halves of the same brain, and that means constant, crystal-clear communication is essential.
There's a quote from the source material that just hits the nail on the head. Teamwork is a safety barrier. And that's not just some nice, fluffy idea. It's a real, functional piece of safety equipment, just as important as any valve or sensor. When that communication is solid, the team becomes a shield that stops errors from getting through.
So what happens when that shield fails? Well, this is it. The most common mistakes are almost always things that could have been prevented. Rushing the job, bad handoffs between the control room and the field, skipping a critical warm-up step, or lining up a valve the wrong way. These aren't just technical glitches. They're the direct result of a breakdown in discipline and teamwork.
And that really brings us to the final, most important takeaway here. Checklists and procedures are crucial, of course, but they're pretty much useless without the right mindset. Professionalism, focus, and a non-negotiable commitment to doing things the right way every single time. In this world, it's that simple. Discipline saves lives.
It really makes you think, doesn't it? We've just looked at the insane level of focus needed in this one specific field. But what other invisible jobs are out there? Like air traffic controllers, or the folks managing the power grid, that rely on this exact same level of disciplined, by-the-book focus just to keep our world running safely every single day.